Hello everyone. In this video we'll be talking about your properties of properties of OLS estimators. So we had discussed about OLS method in the previous video. And how it was used to get your beta 1 hat and beta 2 hat values. In here we will be talk about the properties of these estimators. Okay. So OLS estimators are solely expressed in terms of observables in that is sample x and y. So as we had seen in the previous video, we know that your beta 1 hat value and beta 2 hat value were expressed in the forms of the values of x and y. Okay, so the equations that we had uh, calculated, so they were in terms of x and y. So your beta 1 hat and beta 2 hat are expressed in x and y terms. Okay, that is your first property. Then the second property is they are point estimators. Okay, point estimators. So this means that we get a particular value for your beta 1 hat and beta 2 hat. So there is no range value. So there is no range of values. Okay, there is a particular value for beta 1 hat and beta 2 hat. This is your second property. Then there is a third property. So once we have the OLS estimates, sample regression line can be calculated. So once I get these values, okay, once I get these values, I can easily calculate the sample regression line. So because now I know uh, the intercept, now I know your slope coefficient, okay, and I already know the values of x and y, so I can easily compute this regression line. Okay, now the fourth property is, and one of the property of this regression line is that it passes through the sample mean values, okay, of x and y. So this regression line will pass through, this is x bar and this is your y bar, or this value is your y bar, right? So x bar comma y bar, this is also a property of your sample uh, of your OLS estimators. Okay, now the last point, okay, last property is the mean value of estimated y is equal to the mean value of actual y. So mean value of your estimated y equal to y I hat is equal to actual y mean value. Okay, so this is also a property of your OLS estimate. Okay, so what this actually means is, so the fourth property, what it means is, so my yi hat is equal to beta 1 hat plus beta 2 hat xi, okay, which is equal to y bar minus beta 2 hat x bar, because my regression line is passing through these values. Okay, so these y bar and x bar are a point which will satisfy this equation, and so I can use this in these in this equation itself. Okay, so I've instead of using xi, I have used x bar. Okay, and instead of yi hat, I have used y bar plus beta 2 hat xi. So I've taken your beta 1 hat value from here. Beta 1 hat is equal to yi hat minus beta 2 hat xi, and in here I have used uh, y bar minus beta 2 hat x bar. Okay, because my line passes through, regression line is passing through x bar and y bar. Okay, so this has been put here. Okay, and this is the remaining part. So this is equal to your y bar plus beta 2 hat xi minus x bar. If I open the equation and rearrange the values, I'll get this thing. This is beta 2. Okay. So if I sum both sides, okay, summation yi hat is equal to summation of y bar plus beta 2 hat xi minus x bar, I will get yi hat bar is equal to y bar, because this term, summation of this term will become 0. Okay, so this is also a property of the OLS estimators. Okay, so this was all about this video. See you in the next video.